A container that can hold 6,780 grams of mercury can hold only 797 grams of carbon tetrachloride. Given that the density of mercury is 13.6 grams per milliliter, calculate the density of carbon tetrachloride. Let's try a similar approach with this problem. What are we studying here? Exactly, we are studying carbon tetrachloride, which looks like this, but is actually extremely small. Therefore, we will start with 797 grams of carbon tetrachloride. Now, the conversion factors come in. If 797 grams of CCl4 can fit into one container, what will our expression look like now? Yes, we can change the units of grams of CCl4 to one container, and this one container can also hold 6,780 grams of mercury, which is another conversion factor. We changed grams of carbon tetrachloride to grams of mercury. Are we done with the problem? What's our next step? No, we want to change grams of mercury to milliliters of mercury. What number can we use to convert mass to volume? The density is needed, which is 13.6 grams of mercury for every 1 milliliter of space in the container. So there we have it. We now know the volume that the 797 grams of carbon tetrachloride occupies, 499 milliliters. But wait, the problem is asking us to find the density of carbon tetrachloride. That's okay, we now have all the information that we need. Based on our work, what is the density of carbon tetrachloride? Exactly. Density is mass divided by volume, which is 1.60 grams per milliliter. Some big ideas of solving this problem is 1. To recognize that when different substances occupy the same container, they share the same volume, and understand how to use the density of a substance to convert between mass and volume as required. 2. One last note of caution. Notice that we were really careful to be explicit in our units when we did our conversions. If we hadn't been, we might have done this, which would have been wrong. That is not the density of CCl4, it's the density of mercury.